Anodizing is an oxidation process where surfaces of a part are converted to a hard, porous oxide layer, and it has many applications in building structures, housing appliances, jewelry, vehicle, and computer components. Anodizing is still a popular process today, and the market is expected to grow from 2.37 billion to 3.68 billion from the year 2021 to 2030. Anodizing improves corrosion resistance, wear resistance, and creates a non-conductive surface as well as a decorative finish on the part. In this video, I'll be summarizing the anodizing process presented by Antoine Beer. The link to the original video can be found in the description below. The first step to anodizing is pre-surface treatment. This involves blasting a fine media onto the parts to remove any machining marks. The next step is racking, where the parts are placed onto racks which can conduct electricity, which will be required for the anodizing process. Once the parts are on the rack, we move into cleaning and etching. This is the first chemical steps. The parts on the rack are dipped into a very strong sodium hydroxide solution. This cleans off the parts from any oil from our hands or leftover machining oil. The oil and debris can prevent anodizing layer to build up correctly on the parts, and this process removes some of the thickness on the part which will be added back later. During etching, the non-aluminum elements react with the solution, forming smut on the surface. This step removes the smut with an acidic solution, and the parts are rinsed after this step. Now we can move into the actual anodizing step, where the parts on the rack are dipped into a sulfuric acid where current is passing through. This results in rapid oxidation of the workpiece. The results vary depending on surface area and conductivity of the alloy. Parts are checked periodically during the process until the desired thickness is achieved. After anodizing, a viscous film remains on the surface and needs to be rinsed off. Once that film is rinsed off, we can move into coloring. The honeycomb pores on the anodizing layer allow for a color to be applied, and this is how anodized parts get their color. Once the dye is applied, we move into sealing. The honeycomb pores need to be sealed not only to keep in the dye, but to also gain full potential to chemical resistance. Once the sealing is complete, we move into inspection, and this will be looking for any hanging marks, bleeding dyes, and making sure the features are all anodized correctly. While there are many benefits to anodizing, there are some cons as well. Primarily, the final size of the part and features vary depending on the surface area and conductivity of the alloy. This can mean inconsistent results between batches. The process can only use specific grades of aluminum, and the color selection is limited. This concludes my overview of the anodizing process, and I appreciate your time. Thank you.